For the next segment of this lesson, we will again discuss climate. So you should already know the factors that affect climate from the first lesson. We'll now discuss how these factors affect organisms and the environment itself. But first, let's go through macroclimates and microclimates since these heavily impact temperatures and other conditions in an area. So macroclimate refers to conditions over entire places, entire areas. For example, the type of climate we have in the Philippines, the one that alternates between wet and dry seasons, is our macroclimate. By the way, most people believe that we only have two seasons, which are wet and dry. That's just half of it. We actually have four seasons, but we'll discuss that next time. Okay? It's primarily a more, distinct separation between our two types of wet seasons and two types of dry seasons. Again, we'll discuss that next time. Okay? So microclimates, on the other hand, these refer to conditions that vary in smaller scales. So these conditions also greatly vary based on location and time, meaning that microclimates can change very, very rapidly. So I'll give you an example. Let's say that you have a specific area of forest. Okay? The type of conditions that specific area and that forest can be an example of a microclimate. You can go even smaller than that. Let's say you have a cave in that forest, for instance. Okay? So that cave will have different conditions inside and different conditions outside. So that cave can also be considered its own microclimate. So there are several factors that affect microclimate temperatures. Altitude is one such factor. Obviously, the higher up you go, the colder it gets. I mean, it's pretty obvious in this photo, right? You only find snow on the upper levels of Mount Fuji. And then the lower levels, well, it's just land or plants, I guess. Anyway, so you may also have noticed this if ever you've climbed a mountain before. You don't exactly have to be a mountaineer to notice this. Okay? Merely going up, let's say, Baguio or Tagaytay already exposes you to the lower temperatures that higher altitudes have. So what accounts for this drop in temperature in higher altitudes? Okay? This is because as air rises, as air goes up, pressure goes down. Okay? So as pressure goes down, air expands, and this expansion will cause air molecules to move a lot more. So this increased movement requires energy, and this energy is drawn in from the environment. So as energy is drawn in from the environment, then this leads to a cooling effect in the surrounding areas. So that explains why it's colder in higher altitudes. That's because, energy is drawn in order to power the movement of air molecules. Let's move on. So another factor that affects the temperatures and microclimates is aspect. Okay? So the geographical aspect refers to the directions that a mountain's hill or a hill slope faces. Okay? So this can have significant effects on the topography and the organisms that live within them. Why? This is because depending on what side you're looking at, there are shielding effects against sunlight or precipitation that can occur. Okay? So if this is unclear, I'll give you an example. Okay? So in the northern hemisphere, the northern aspect of mountains, which face away from the equator, receive less sunlight than the southern aspect. Okay? Let me try to draw that. Let's say you have the Earth here, you have the equator, you have a mountain. Okay? So the northern aspect of a mountain, which is the other side of this mountain, faces away from the equator. The southern aspect, on the other hand, is this one, the one that we see. Okay? So this means that the northern aspect will receive less sunlight than the southern aspect. Why is that? Remember, again, from the first lesson, we mentioned that most of the Earth's sunlight is abundance of sunlight is higher in the equator. So sunlight mostly shines from this area. Okay? Which means that the northern side of the mountain is shielded. So what are the consequences of that? I'll give you another example. Okay, so the photo here shows a north-facing side with lots of trees, so this side, and a south-facing side with mostly grasses, so this side. Okay, this is because in this particular region, the south side receives more sunlight, which means that it's drier than the northern side. Okay, so this is drier than the northern side, which accounts for the abundance of grasses. Now, take note that in regions closer to the equator, the sun shines on both aspects more or less equally. So the changes or the differences between north and southern aspects are less pronounced. But, of course, other factors may still affect topography. For example, Sierra Madre. Sierra Madre in the Philippines, of course, obviously close to the equator. Okay, so in a way, the different aspects of Sierra Madre have roughly the same amount of sunlight. But one such factor that is prevalent, or one such difference in a factor that's prevalent in Sierra Madre is rainfall, with one side receiving more rainfall than the other. So it's not just about sunlight. Okay? Other factors also affect the aspects of a mountain. So another factor that can affect the temperatures and microclimates, you have vegetation. Okay, so plants can also affect microclimates. These create shade and release organic material, for example, in the form of falling leaves, that can significantly alter temperatures in the areas that they affect. So examples are canopy covers and foliage blocking out sunlight, creating cool spots underneath. So you also have leaf litter that covers the ground, which also lowers temperature. Next, let's discuss the effect of ground color on microclimates. So some soil, sand, or ground colors heat up faster compared to others. So this is related to the amount of light that these colors can absorb from the sun. For example, even under very similar macroclimates, black sand can heat up faster compared to white sand. Also, black sand can remain at higher temperatures for an extended period of time compared to white sand. It cools down slower. Okay? This is because the color black absorbs more light from the visible spectrum of light compared to the color white, which reflects more light. Okay? Finally, let's discuss boulders and other refuges and how they affect microclimate temperatures. So burrows and other refuges serve as useful hideouts for organisms from sunlight. I mean, for obvious reasons, because these things block out sunlight and the areas underneath them are a lot cooler than the areas that are hit by sunlight. Okay, so these areas are shielded from the sun's rays, which leads them to having lower temperatures, which can be optimal or can be beneficial for the organisms that prefer these lower temperatures.